Please open in your learning workbook to page 140. Let's solve some ALEX problems involving composing functions and specifically finding domain. For the real valued functions, f of x equals x minus 4 over x minus 3 and g of x equals 2x minus 1, find the composition f composed with g and its domain. The first thing that I notice about this problem is we're missing the of x part of this. The instructions simply state f composed with g. But since f is a function of x and g is a function of x, then when we compose the two functions together, the result will also be a function of x. Therefore, we may write f composed with g of x. That's what we're being asked to find in this problem, as well as its domain in interval notation. All right, let's proceed. First, we use the definition, f of g of x. We notice that we have a variable on the inside, so we work from the outside in. We begin with function f, and specifically the right-hand side. We're going to write this fraction, but everywhere we see an x, we are instead going to put g of x. Okay. Now we're going to substitute. We know that for this problem, g of x is equal to 2x subtract 1. So then we have the following. 2x subtract 1 minus 4 for the numerator. 2x subtract 1 minus 3 for the denominator. Notice that I don't have any parentheses in either place because even though I'm substituting g of x with something new, g of x does not have any exponents, or any multipliers, or any subtraction symbol in front of it. Now, this is the first line of our algebra where we have no function names anymore. Look, our function names for this problem are f and g, f and g, g, g. This is the first line of algebra that does not have f or g in it. So this is where we stop and determine our domain. We know that domain is a four-step process, and specifically that we're looking for even radicals, logs, and denominators. The only thing that we have in this problem is a denominator, and denominators are not allowed to be 0. So 2x minus 1 subtract 3 is not allowed to be equal to 0. Let's solve this. 2x subtract 4 is not allowed to be 0. Adding 4 to both sides gives us 2x is not allowed to be 4. Dividing by 2 on both sides gives us x is not allowed to be 2. Our domain is the set of all real numbers except for 2. And as an interval, it would look like this. Negative infinity, going all the way to 2, and then skipping over the value at 2, and continuing on to positive infinity. Now that we have determined our domain, we go back to our problem already in progress and continue simplifying. Combining like terms in the numerator, I get 2x minus 5. Combining like terms in the denominator, I get 2x minus 4. Now, can I cancel this 2 with this one, or this x with this one? The answer is no. And the reason why is because of these two subtraction signs. Only factors can be canceled, and only when they match top and bottom. Factors do not have subtraction signs next to them. So, this is our final answer for this problem. This is asking us to find f composed with g of x. And this is asking us to find the domain of f composed with g of x. Okay, let's move on and do another ALEX problem. right, our next problem says f of x equals x squared plus 3. G of x equals the principal square root of the sum x plus 2. And we're asked to find f composed with g and its domain as an interval. Okay, let's proceed as we did before. F composed with g will be f composed with g of x. Rewriting using the definition, we get f of g of x. We have a variable for our input, so we work from the outside in. That means we start with function f, specifically the right-hand side, and we write what we see on the right-hand side. But everywhere we see an x, we're going to put g of x instead. Substituting for g of x, we have the following. The square root of x plus 2 in parentheses squared plus 3. This is the first line of algebra where all of our function names are gone. So this is where we stop and determine the domain. Now I'd like to talk to you just a little bit about why it's so important to stop at the correct time. You probably know that when you have a square root and you square it, the square root and the square cancel, leaving you just what's underneath. Eventually we are going to simplify this. Not now, but eventually, and when we do, this will turn into x plus 2 plus 3, which will simplify to x plus 5. X plus 5 has no even index radicals, no logarithms, no denominators. Therefore, if we looked just at the x plus 5, we would conclude that the domain is all real numbers. But for this problem, the domain is not all real numbers. And that's why it's so important to stop at the correct time. So, now that we know that we're stopping at the correct time, let's go off and determine our domain. This is what we're going to determine the domain of. Notice that we have an even index radical. So anything underneath has to be greater than or equal to 0. X plus 2 has to be greater than or equal to 0. Solving this by subtracting 2 on both sides, we get x is greater than or equal to negative 2, which is the interval bracket negative 2 comma infinity parentheses. There are no logs or denominators in this problem. Therefore, this is our final answer for the domain as an interval. Now we will go back and continue simplifying. Let's repeat what we have here. The square root of the sum x plus 2, all in parentheses squared, plus 3. The square and the square root cancel, leaving me x plus 2. And combining like terms, we get x plus 5. So there were 2 questions, and therefore there are 2 answers. Find the composition f composed with g. That would be this answer. And its domain. That would be this answer. It is very, very important when determining domain of a composite function to stop as soon as all of the function names are gone, step to the side, determine your domain, then return to the problem and simplify.